You're welcome to today's class. Still on variable scope and storage classes, right? I'm just going to write a program to illustrate what I taught you in the last class. I didn't want that class to be too long, so that was why I had to cut it. Now I'm just going to write a program to demonstrate those variables for you to see. Without wasting much time, so let's write, say, include stdio.h, right? Now I'm going to declare a global variable. So I will say int global var, and I will assign 40 to it, right? I'm going to declare an extend variable. So I will say extend int, let's call it, let's give it a name, right? Let's give it a human name. I'm going to call this infon, and then, so because it's an external variable, it's a noble from another kingdom coming to this kingdom, I am just declaring it here without assigning a value to it because it already has a value in its own kingdom. So it means I'm going to create another file, and I'm going to say int infon, right? And then I will assign 10 to it. So this is another file that I've created, and I've created this variable. So I'm telling my compiler that this variable, right, this variable is from another kingdom. So go to that kingdom, there is a linker that will have to link them together. So I have to compile it inside the same file. And then, so it's going to link it to this place to pick out this value. All right, so then I'm going to create a function. So I will say int, that function is not going to return, just going to perform a task. So I will say void, and then I will say code rem. Then this code rem, I'm going to supply parameter to it. So int param, right? Then I will come into the function. So inside this my code rem function, I'm going to declare a static variable. So I will say static, right? Int. So I will just call it static variable, static var, and I will assign 30 to it. This one, I'm just going to declare it this way. Now, because it is static, even if I don't assign any value to it, the default value will be what? 0. The default value will be 0, right? The default value for static, default value. Default value for static will be what? 0. Okay. Now I am going to declare another variable. I will call it register. And I will say int. So reg var, right? I will assign 30 to it. Then I will declare another variable. I will call it local. So I will say int local var. I will assign 24 to it, right? Now, what do I want to do with this static variable? I will increment it. I will say static var plus plus. So I have increased the value. So the default value was 0. So by doing this plus plus, meaning I'm going to increase it to 1. That is what it means. So what will I do now? I will now call my print function, print f, and I'm going to print out, I want to see all the values of each of these variable. So here I will do this, then I will say global. So this is a string literal I'm supplying here, global. So I want to print out the value of this global variable. So I will give my format specifier to hold it. Then I will do this. I will say um, param. Param. I will do this. Format specifier. I will hold this, comma. Static. I will do this. Format specifier. Percentage D, comma. You will not be able to see. So I'm supposed to continue along that path, but I'll just come down to write what I should have written there. So that is for static. Then what's the next one? Register. The register variable, format specifier, comma, then local variable, local, format specifier, um, comma. Then I also want to print out this extern. So from, right, format specifier, D. Then I will do slash n. I will close my curly bracket. Then comma. Now I have to supply the values from each of the variable. So this global is expecting this will be printed out on the screen. Global will be printed out on the screen. Pattern will be printed out on the screen. Static will be printed out on the screen. Register will be printed out on the screen. Local will be printed out on the screen. And form will be printed out on the screen. Now slash n. So what are the values is expecting? So this is an expression that is expecting a value, is a placeholder, format specifier. So what will it be expecting? This is global. So I will have to supply this. This should be in a straight line, but because of the size, so I will supply global var, comma, param, comma, static. So this one will take static var, comma, register. So reg var, comma, local. So local will take, I'll come here again and write local is one word, var, comma, and then font will take, then we'll close this. So this is my program. So this is the function that I've written. Now I'm going to close this my function. So I'll come here and I'll close it. All right. Now I have to write my main function so that I can call this function. So I'll just clean this. I don't think you'll be able to sit down. So let's write it here. So let's write our main here. So int main. So I want to call this function. So I will say code rem. It's expecting one parameter. So I will supply one to it. Then I will call it again. Code rem. I'll supply two to it. Then I'll say return 0. Then I'll close this. All right, so that's my main. So what happens here? I have given my storage classes. I've defined the storage classes when I'm writing this program in the code rem. So a physical memory location has to be created, meaning the physical word, landmass has to be created. This community has to live somewhere, but everybody must follow this title that is given to each one of them, whether family or individuals. Now I'm going to call this function here. When I call the function code rem and I'm going to supply one to it, so meaning that is the first time. So one will come here, then you will enter into this place. Static int, static variable. This variable will now be created. So the memory location for this variable will be in what? Data. Data segment of the memory. Data segment of memory. The whole of this program, global variable has been created in the data segment too, and 40 assigned to it. Extern has been declared, right? telling the compiler, but this extant is created somewhere else. So I'm calling it, that is, I'm inviting a noble from another community to an event in my own kingdom. Okay? And that noble is carrying the value 10. Okay. Now, you call the function. Then you enter into that function. This static variable will be created. But because it is static, it will not be created inside the same stack memory with this function. It will be created in the same place where this global variable and this external, which is data segment, where they are created, right? Then register. So reg variable will be created in the register of the CPU, and 30 will be assigned to it. Then local variable, this is what? Ordinary citizen of this kingdom will be created when this function is called. So 24 will be assigned to it. So it has the function, this is the function, memory space for the function. Now this local variable will be created inside, and then 24 will be assigned to it. But this static is created outside, and the default value is what? 0 for static. Then regular is also created in the register, right? So 30 is assigned to it. That is the CPU register. Okay. Now, when you get to this place, static variable plus plus. So before you call the print function, you are going to increment static. So static will increase to 1. Static will increase to 1. Then you come to the main function and you call. So when you get to this, once static increase to 1, it now gets to printf. So printf wants to print out all the values of the variables. So the first value, which is global, will be called because this function can access this global. You know, the king can access anybody in the kingdom. So this function will access this global and to print out 40, right? Then param 1 was applied to it, so it will print out 1. Then static, which is this one, it has incremented here to 1, so it will print out 1. Register is what? 30, it will print out 30. Then local is what? 24, it will print out 24. Then mfon is what? 10, it will print out 10, right? I don't know whether you are still seeing that. If not, so let me bring this back. Yeah, so 40 param is what? 1. Then static is what? 1. Then register is what? 30. And fun is what? 10. Local is what? Yeah, 24. Then fun is 10. So it's going to print this out on the first line. It will print it out on the first line. Then it will return to this because it will return back here. Once it encounters this one, this place, it encounters this curly bracket, it will return back from here. It will return back to where it was called. Because initially it was called to this place, right? Initially it was called here, like this. Now it has come, gone around, and then it has returned back. The moment it encounters this variable, right, will be gone. This function will be gone. The reg 2 is still inside the CPU register, right? Now it's going to call it again, the same function again. So control will come back here. It will repeat the same step. But this time around, what is the value supplied to param? 2. So at the time it exits, whatever value was in this param, is called by value. It was just a copy that was given. That variable was gone. It disappeared. Now you are reassigning another value to param. So param is now what? 2 instead of 1. Then it will enter this function again and it will print static variable. Don't forget, this static variable was not created in the same space with that function. So when the function exited, it did not destroy the static variable. So static variable was still holding the value. So the priest can still remember the past of how the entire function was created. So whatever the value of the priest was then was 1. The priest retain it. Now, 30 is assigned again to reg variable, which is in the register of the CPU. This variable is created again, and 24 is reassigned to it. Then static is going to increase. The value of static is 1. So increasing it will now be what? 2. Static will now be 2. Then it will now come back to this printf to print it. So what is it going to print? The global variable was still alive. It was not destroyed. The moment this program started, global variable was alive. It only returned back to this place because main is still active. So global variable remains the same. So it's going to print 40. Right? Then, so param will now print 2. Then static will also now print 2. Register will print 30. Local will print 24. And then phone will still print the same thing, 10. But watch what happened to param and static. Param and static value changed from the first time you call the function to 2 and 2. So that is the point I'm trying to make, that the value for global variable remain the same because the lifespan of it will be until the entire program is gone. So until that kingdom is destroyed, certain values will remain the same. You can't change it. You have to leave it that way. You cannot touch it. Any attempt to change it will affect the entire system. The extern, depending on how it was defined in his own kingdom, whatever it is there, that is what will still come to this side. The static variable, same thing. The priest, a memory location will be created outside of the local variable of the function. So it will retain its memory. Register can always be reinitialized, but local variable will die or will go along with the function. Right? So that is what I want to demonstrate to you. So what affects a variable is what? The storage class. The storage class that is attached to that variable will determine what type of citizen that variable is. Whether it is the king, or it is ordinary citizen, or it is special agent. Is very, very important. So when you are writing a program, you must be conscious of whatever is defined as the storage classes of that variable. If nothing is defined, that means it is auto, which is the same thing as a local variable. That is why we are using it in a loop. You will see how for every iteration of that loop, the variable will reset itself. Because once execution leaves that scope, everything that was created in that scope would disappear. So if nothing is defined at the beginning of a variable and the rem, it means it is auto. So that is what I want to demonstrate to you in this class. So let's go to code block. Let me run this program, and then you see what the output will be. So this is our code block. This is the program, what I explained to you on the board. So this is the global variable. We assign a value to it. This is the extern. Now, if you look at it, I have actually created both. So if you look at this place, this is where I declared my variable int phone, and I assign 10 to it, right? Now, I am writing this program here, and I'm calling extern, using extern, telling the compiler that this phone is a variable that is existing somewhere else. So I have used my linker to link these two programs inside one project, which is what you are seeing here. So you can see there's no value assigned to phone here, but it's going to print it out. Now, this is my function. It's not returning any value, but it's expecting just one parameter. So I have created a static variable, then the register variable, then the local variable, which is auto, Then I incremented my static variable. So this is my printf function to print out everything. This printf is like a variadic function. So it's going to accept as many parameters as possible. Now I'm calling the function 2 times. The first time I supply 1 to param. Second time I'm supplying 2 to param. So let's run this program and see what the output will be. So I'm just going to, so you see, now nowhere will you see the value of fun. But look at when it printed out following this printf, it printed out 10. So the first time you call the function, it printed out 40, param 1, static 1, regvar 30, 24, 10. When you call it the second time, it printed out 40, param has changed to 2 because you supply 2 here. Now, then static is now 2 because in this place, static was 0, right? Static was 0. Now, if I do this, yeah, that was why I wrote this. The first time, I can tell you the value of static. So with this printf, I will print out the value of static. What will be the value of static? By default, is 0. So when I run this, you will see it. All right, so look at this program. So the first time, static was 0. Then it printed out all this because this increment here increased static from 0 to 1. That is why it gave you this as static variable as 1. Now, when you call the function again, it retained that static variable as 1 here. But when it's now going to do printf, after increasing it again, it now gave you static as 2. You see, it's incremented static. So static didn't lose its value even after the function returned. So that is what I want to explain to you. So the static, even though it is local to this code rem, but it was not created in the same place with the local variable. It was created in the same place with the global variable and font variable. So that is what I want to demonstrate to you in this class. So don't just go about altering the design of a system simply because you think you have the power to do so and you don't have access to the source code. It will completely disrupt that program. There will be an error message given. So if you want to change anything at the front, then you must go to the back end, having access to the source code, change the source code before you can alter anything in the physical space. That is what I want to show you in this class. So till we see in the next class. Bye-bye.